Welcome back. This is a continuation of what we started yesterday, and that's joint variation. So we go straight to the example we copied. Now, they said x varies directly as y and inversely as z. When y is 7 and z is 3, x is 42. Question A, find the relation between x, y, and z. And B, find x when y is equal to 5 and z is equal to 9. That's a piece of cake. We go straight to the solution. Now, of course, just as a quick review, if I write this, if I write this and this simply means x varies directly as y, which you would write as x equals ky, while this, where k is a constant, while this simply means x varies inversely as z, which you write as x equals k over z, where k is a constant. But if you have it this way, x with a sign of proportionality and the ratio y to z, it simply means the two variations have been combined into one. The direct and inverse variations have been combined into a single representation. And what that simply means is x varies directly as y and x varies inversely as z. The denominator is the one inversely as which x varies, while the numerator is the one directly as which x varies. So, having said that, I think we can go through the solution very, very simply and without hitches. So, we said the first question is A. You write the relation down, the expression of proportionality down, and they said x equals y. If that is so, that simply means x equals ky over z, which means k, of course, if you cross multiply, this means x over 1. So 1 times ky will be ky, and x times z will be xz. So that means k, if you divide both sides by y, that means k is going to be equal to, of course, y cancels y, and that means k equals xz over y. And we know that x equals, from the question, x equals 42, y equals 7, and z equals 3. X equals 42, y equals 7, z equals 3. So that means k is equal to 42 times 3 all over 7. And that simply means, of course, 7 here 1, 7 in 42 is 6, and 6 times 3 is 18. So that means k is equal to 18. And now, what's the question? Find the relation between x, y, and z. Therefore, the relation is simply this. The relation is simply this. It's simply this, what we got before we made k the subject. And that's actually x equals ky over z. So instead of k, we now write the value we obtained for k. So therefore, x equals k, which is 18y over z, is the relation between x, y, and z. That's it. Every time you have to find the relation, just find the value of k and put it in the equation that has all of the terms given, including z, and that's it. Now let's go to B. What's question B? That says find x when y equals 5 and z equals 9. When y equals 5 and z equals 9. When y equals 5 and z equals 9. When y equals 5 and z equals 9, x equals 18 times y, which is 5. Of course, let me rewrite that to remind you. 18y over z, which is equal to 18 times 5 divided by 9. And that's 9 here 1, 9 here 2, and that's 10. So x equals 10 when y equals 5 and z equals 9. And that's that. I think I want to take another example. Let's call that example 2. Still on joint variation. Example 2. I don't have that already. Let's check. Joint variation. This proportion, and this is let's find that that's supposed to be here. I think I have to check the variation. Okay, yeah, right there. Now t, example 2, t varies directly as big S and inversely as small t. When S equals 36 and t equals 16. When big S equals 36 and small t equals 16, big T equals 27. Question A, find the formula that connects T, big S, and small t. And question B, find T when big S equals 33 and small t equals 18. Solution. Let me select a yellow ink. Now here, so we start with A. The relation is the relation of proportionality is T varies directly as big S and inversely as small t. Now that means T is equal to Ks over small t. And now when S equals equals 36, small t equals 16, and big T equals 27. Okay. Oh, I think I needed to find before. I would like to find K before writing this. From here, we cross multiply, and that means Ks, because the essence here is to obtain K. Ks equals big T times small t. And now if you divide both sides by big S, K is going to be equal to big T times small t all over big S. Now, you can copy that, paste that back. So when big S equals 36, small t equals 16, and big T equals 27, K will be equal to big T, which is 27, times small t, which is 16, divided by big S, which is 36. And that simply means 9 in 36 is 4, 9 in 27 is 3, 4 in 4 is 1, 4 in 16 is 4, and the answer is 12. So, therefore, they said we should find the formula connecting TS, big T, big S, and small t. And of course, that formula is T equals KS over T. Now that we have found the value of K, that's what we just do. We just write T equals K, which is 12, times big S. Be careful not to make your big S look like a 5, so that you don't take that for 125. Big S over small t, which is big S over small t. Therefore, T equals 12S over small t is the formula that connects big T, big S, and small t. Now to question B. Question B says find T when S is 33 and when big S is, find big T when big S is 33 and small t is 18. So we already know the formula. The formula is T equals 12S divided by small t. That means when big S is 33 and small t is 18, big T is going to be equal to, big T will be equal to 12 times big S, which is 33, divided by small t, which is 18. And then we can go, 18. And then we can go 6 in 18, 2, 6 in 18, 3, 6 in 12, 2, 3 in 3, 1, 3 in 33, 11. And that means 22. So, therefore, T equals 22 when S equals 33 and small t equals 18. And that's it simply. I'm going to take one last example. Let's see what that could be. One last example. Yeah, let's take that. Example 3. The mass of a sheet, of paper of a sheet of metal varies jointly with its area and its thickness. A sheet of A sheet of metal, of area 250 centimeters squared and thickness. A sheet of metal of area 250 centimeters squared and thickness 1 millimeter has a mass of 200 grams. Question A. Find the formula. Find the formula which connects the mass m in grams. That means the unit of mass is m, and the unit of mass is grams, and it's represented by big M. The mass m in grams, the area. They're already giving you symbols to use for the parameters. The area, big A in centimeter squared. Symbol is big A and unit is centimeter squared. And the thickness, let's see what that's going to be. And the thickness, small t in millimeters. That means the symbol for thickness is small t and its unit is millimeter. B, hence, find the mass of a piece of metal of area 400 centimeters squared and thickness 3 millimeters. This is our last example actually on joint variation and thickness 3 millimeters. So let's see, that looks like a long one, but I'm sure it's simple. The mass of a sheet of metal varies jointly with its area and its thickness. Mass, what does that mean? A sheet of metal of area 250 centimeters squared and thickness 1 millimeter has a mass of 200 grams. Find the formula which connects the mass mg, m in grams, the area a in centimeters squared, and thickness t in millimeter. All right, that's solution.